Welcome to the RoadCast. I'm your host, Carsten Karcher, Secretary General of EAPA, the European Asphalt Pavement Association. Today's guest has a reputation for achieving a great position in his research career at a young age. He began his career as a civil engineer at the Technical University in Vienna in 2007. Over the years, he progressed to become one of the youngest professors at the university's Institute of Transport Science, specializing in road engineering. While he is known for his expertise in technical subjects, today we will hear from him his inspiring career journey and his work as a university teacher. Working closely with young people, he has valuable insights into their evolving behavior and the challenges they face as they prepare to enter the industry. This is crucial knowledge for an industry eager to understand and support the next generation of professionals. Welcome, Bernhard.
Well, thank you very much, Carsten. It's
Yes,
funny
we
to
are not.
talk to you in English because usually we speak German, right? But for the wider audience, I think it makes sense to switch to a language that more people can understand.
I would prefer to. I would love to do it in German, but of course, you mentioned the reason why we do it in English. So we try to do our best in this language. At least I try to do my best. You are much better than that.
Yeah, still not my first language, but yeah, we're both used to it. I think we will get around.
Yes, we will get around. So unfortunately, we are not in the same room today because you are currently in a different time zone. Where are you?
I'm actually still in Montreal, Canada right now. I'm attending a conference here, and so I'm 6 hours ahead. No, I'm 6 hours behind. It's still morning where I am, and
Yeah.
you already spilled your afternoon coffee on the desk I heard before the recording. I
Shh,
would
don't
like to
tell
have that
people.
coffee because
If it's not that
uh,
inspiring as all the other podcasts have been, it's because I spilled my coffee. Okay, good, good. So,
yeah.
my first question to you would be, was it always your plan to become a professor, a university professor in road engineering? Was this your career plan?
I think if you ask any kid, is what is your future plans? A very small number of people would say, I want to become a professor in road engineering. So no, definitely not. I was in a non-technical high school. We have different high schools in Austria, and I was in a non-technical one. So I had no idea about civil engineering in my earlier education. In fact, it was rather difficult for me because I had many different interests. That spanned from history to languages to chemistry. When I was close to graduation of high school, I still hadn't figured out what I wanted to do. And then one of my teachers came up to me and said, "You know what? My son is studying civil engineering. I think that's something that could be interesting for you." And so I said, "Okay, well, let's take a look." And I went to Vienna from my hometown, which is about 1.5 hours away. They had open house at the university, which we have every year, where we give introductory lectures to show to interested people what's the span of civil engineering is. And I thought, yeah, okay, sounds interesting. Let's give it a try. And so basically, if it wasn't for my one of the teachers in school, I guess I would have made something completely different, and we wouldn't be sitting here together.
That would be a pity. Yeah, yeah. So great start. So we hear that you are from Austria, school, or you visited high school next close to Vienna or 1 hour away from Vienna. Interesting.
Yeah,
So and then you started studying at the university, Technical University of Vienna, civil engineering, I guess.
right. Yes, so that there was a civil engineering program that I started, and it was challenging. I mean, yeah, as well as any other civil engineer that it's a challenging study. There is lots of maths and physics and especially mechanics. And I had no clue about many of these things because, as I said, we have technical high schools in Austria that already focus in the last 4 years of school on civil engineering, for example. So they come very well prepared, and so in the first 2 3 semesters, it was a struggle to keep up and to get used to terms in structural engineering that I have never heard before. I just had general physics and general maths, but not so much focused on that. But it's such a broad program that no, I want to stick to this, and I want to finish this and see where the road is going to lead me to. And then by, well, I don't know if it was by chance, I did a lecture at my mentor to be, Ronald Blab, and he offered, or he showed master thesis positions, and they had at that time a big research project, very fundamentally oriented research project, and it sounded very appealing, and it was with experimental work, and I knew that I was interested in experimental work. I wanted to do something with a material, and so I started in the road engineering lab. As a master student, I did my master thesis on um, modeling of viscoelastic behavior of our materials. And I found out that it's a very complex material, but also a very interesting material, maybe because it is so complex. And after my master thesis, there was a PhD position at the same institute, at Ronald's Institute at that time. And yeah, that sounded also very interesting. So I stayed on and carried out my PhD thesis, which was a very specific topic, triaxial behavior of viscoelastic material. A lot of experiments, a lot of modeling. That's actually the road that led me towards road engineering.
And also into the research. I remember being at the university in Germany at the same time that there was this big research project of some German-speaking universities also working together in this field. But especially, I was interested in that what the Technical University of Vienna did. Also, I think it was the first time when we most probably met in those years. So in your early university years. And and I always followed your development and your different steps that you took. And what happened after you had finalized your PhD work and became a PhD student? What happened then?
I had my PhD project, and I was also a research assistant. First of all, the team there was very nice, and a dedicated young team of people. When I was still in my PhD studies, our head of the lab, then Karl Kappel, who is still a very cherished friend and colleague, and is still in the field, just in another position like you are. And that's the nice thing, I think, about our community, right? It's a rather small community, and it's a friendly community. And even though we are not always of the same opinion and we have different stakeholders, I think in the end, the good thing is that we are always the idea is to find solutions and not to stick to some single stakeholders' ideas if it's necessary. So, anyways, so he left to the industry, Carl, and the position was vacant. I was not finished with my PhD, and Ronald somehow came up to me and said, we have this position now, head of the lab. I know you're not done with your PhD. I know it's going to be additional work. You might need some extra time for your PhD for if you do that in parallel. But if you're interested in staying in research, and then that's now or not never, but not in at TU Wien, because he would have had to fill the position with someone else, and then that would have closed. So I thought, okay, I wanted to stay in research. I knew that at that time because it was just really interesting, and we had lots of facilities in the lab. So I agreed. I took over the lab that was in 2010, and then I finished my PhD in 2011. And since 2010, I'm heading this lab, which is already 14 years by now. This is crazy. It's been a great journey ever since, with lots of course, up and downs, but lots of different projects. Of course, taking on new responsibility, and that's then the scientific career just moved on, and I spent a year, which is also very nice. I spent a year abroad at the University of California in Davis with John
Mhm.
Harvey, a great team there. And that's I mean, if you ask my team members, they can't hear about that anymore, because every other week I find a story about how great it was when I was in Davis. But it really was, because that was a year where I was stripped of all my administrational duties. I didn't have a team to lead. I didn't have projects to manage. I just had myself and a very big amount of freedom with John Harvey's team. And that was so productive in terms of my scientific work, my independent scientific work. And I had, a young family back then, two young children, and my wife, who's a musician, and she was able to really um, uh, take a break and spend the whole year with us in Davis. So it's just, also on a personal and professional level, I really cherish these memories still.
Yeah, it sounds like that. And I also heard some of the stories from that time from you already.
Yes, I know. And I'm afraid that I will repeat myself when time progresses. But for now, I still have enough new stories that I can tell
Yes,
about
yes,
it.
yes, yes. We are working on new stories now.
Yeah.
Excellent, excellent. So, and then you came back, and you came back again to the Technical University of Vienna. And to make a long story short, now you are the what is exactly your position now and your role? Please explain that.
I'm now head of our research center. So I became there were a few steps between. I became full professor, which is maybe a little a special situation since Ronald is still active, but he's a dean of our faculty, and I had an offer from another university to become a full professor there in Germany, and TU Wien wanted me to stay, and so they offered me a similar position. And so I became full professor in road engineering. And then uh, just this year, yes, there was this year, I took over also the research center. So now it's not only the lab, it's also, of course, our administration now, and another working group of my colleague Lukas Ebertsteiner. He's more in modeling and construction technology. I'm heading those two working groups now,
Mhm.
and that's what I'm basically. That's the title, at least. Research
Mhm.
center head.
Yeah. Okay, great, great. And I know from the content of your work that you are really familiar with all the aspects of asphalt and bitumen. Might it be the rheology, might be the practical behavior of this materials. So and also chemical perspectives on this. So I'm deeply impressed about the content or the widespread of the work you do. So that's really impressive, I have to say. And you are, at least I can say from my side, you are one of the highly appreciated, respected professors, even in your young age, in this field in Europe. And as you can see, you are in Canada right now, also worldwide, which makes you a perfect person to talk to today in the podcast and to hear about how a career like this looks like, can look like. Not all the careers are similar, and not every professor have the same possibility as you to get in this position in younger years. So we are not so young anymore. We have to be honest, okay?
Well, yeah, that's what I wanted to say. You put an emphasis on young. I mean, if I look at our students, and if I look at, and if you again ask my team members, they wouldn't agree to that. Let's agree on relatively
Yeah,
relatively young.
relative. Everything's relative, and I can say you are not in your 20s anymore.
No, by far not. By far
By
not.
far not.
Although
Okay.
I still feel like it, and I
Yes,
hope
yes,
you too.
all of us, all of us. Yeah. Siobhan mentioned something
Yeah,
similar in the podcast. She was making jokes.
yeah,
Who looks younger, she or me? That was that was good. Okay.
yeah, yeah, yeah. I mean
Um,
that. Yeah.
no,
No,
no.
go
What?
ahead.
What?
Go ahead.
Please, please.
I'm just saying, I mean, we have an ever renewing pool of people at the universities, because they start at the early 20s or late teens, and then they graduate when they are 25. So that's how I see that time goes on, because interestingly enough, they become younger and younger. So I think that we stay the same, but it's just that the young people are getting younger. So that's the strange phenomenon.
I had exactly the same perception when I had my 15 years at university. Whenever the new semester started, I thought, wow, they are so young now.
Exactly. Sometimes I'm like, I think they are just the high school students who are interested in our studies and we give
Yeah,
introductory lections. No, they are
actually,
already
yeah.
full grown students.
Yes, they are. They are, and
Yeah,
this is just the perception of those who do this, do the same kind of work at university, the teaching every year. So you get older, but the students, of course, are still 18 or 19. But your personal perception is different. That's funny. I had exactly the
exactly.
same with it.
Yeah,
Yeah, yeah,
yeah.
yeah. What do you teach them? So what is the content of the studies you provide at the Technical University in Vienna?
It is complex because it's a wide field that covers. If I talk about now applications before I go into details on or some overview of what we're teaching is, I mean, we have the classical structural engineering, but we also have hydraulic engineering, we have research management, we have waste management, we have material science. Of course, we have transportation. We have the planning and design part. We have the construction part. We have the use part. We have the recycling and recovery part. It's about economics. It's about technical stuff. It's about the environment. It's about society. So really, it's a big part. And what we start with is like with any other program. There's lots of fundamentals that you need to learn. It's maths. It's physics, mainly mechanics, a lot of mechanics, chemistry, and then of course all the more applied structural engineering parts on different materials that we use, whether this is concrete or steel or wood, or of course asphalt and bitumen. And then also the different applications, as I said. I mean, we have a strong part also in waste and resource management by now. Hydraulic engineering, so anything that has to do with water, sewage, and then structural engineering, and so one of the paths that students can decide in their master. So the bachelor is really a common bachelor where they just have everyone has the same subjects, and then in the master they decide on where they want to specialize on, and that is when they can also choose transportation studies. Let's call it that. And that is still again a wide field, right? You have railway engineering, and you have transport economics, and you have traffic planning, and you have urban planning that is also strongly connected to transport science. And then of course you have road engineering, and road engineering again covers the field from planning and design to construction, operation, maintenance, and now more and more important, recycling, assessment of materials, not only technically, but more and more importantly, environmentally, of course, and also in terms of the responsibility we have to society, because we are as civil engineers and road engineers, we are strongly shaping the world in which we live in. And that's a very big responsibility, not only technical responsibility, but also responsibility for the people we are shaping the world for.
This is a very good sentence. So I like the term civil engineer. We do work for the society, the world, the society just around us, the bigger society. So that means everything that has to do with construction, with built construction or the built environment is done by mostly civil engineers. And they are a very important part of this. It's not the economics, it's not the architectures, it's the civil engineers. And we have a big responsibility for the society, and we have to be aware of that. And I think also the status in the society of civil engineers should be shall be much higher than it is at the moment, because the society as such does not realize the great work and the great impact civil engineers have on them. And you just showed this picture with yeah, and you just showed the picture what this engineering that we do is all consistent of, what's all in there. And I think if you are a good engineer, or even if you are a normal engineer, you can be very, very proud of that, what you do for the society. You had mentioned so many things, the environmental aspects, the sustainability aspects, the climate change aspects which come into this. We all have to deal every day with that in practical reasons, in practical matters. And yeah, it's such a wide field of topics that we cover. So and you as one of these professors teaching this, so you have a very important role in my eyes, and I think the people should realize that, the society.
Yes, I think the responsibility for teachers in university I mean on any level, but of course also on the university level, is that we are shaping perception and minds of young people who are interested in this field. And it is important, and I'm not sure if we are also always so aware of the responsibility that we have, because the things we teach them is the things that they are going to go out with, and that the tools that they have at hand when they go out of university is nothing static, it's nothing constant. We have to be in a, you know, in a feedback loop with a lot of stakeholders, like, you know, EAPA and the industry, our road authorities, but also society as a whole. What is the need? Are we shaping the world in a way that is still beneficial, or are we doing too much? So making sure that we're really serving people in what we're doing. And I think that is true for any field. It's just that since we build the environment, or we change the environment, and our structures are not there to be for a month or a year, or, you know, like a bouncing house. I mean, a bouncing house, you just fill it up with air, and then you let it out and you move it, and that's not what we have structures like that, but our normal structures are structures that are here to be for 20, 30, 50, 100, 150 years. And we see examples, we see good examples, and we see bad examples, and learning from that, together with the feedback that we get from society, but also feedback that we get from students, is important to keep evolving the field and the programs and what we teach, and which tools we provide our students in the future, who are the future the future experts, that will keep shaping the world and keep helping to solve problems we are facing.
Fully agree. And you mentioned that the structures civil engineers build are there for decades. Yeah. When you compare this with an environment, or in a society where you have mobile phones that you use for 2 years and then you throw them away because there's a new edition, which is a totally different perception and also strategy. So this is what we do, is long lasting. And when we construct, or when we design, or when we build a structure today, might it be a railroad, might it be a road, might it be a tower or a bridge or a dam or whatever, we have to already consider what will happen with this construction, or with this structure in 10, 20, 30, 40 years. And we also have to think, what happens if we one day have to deconstruct it? How can we use the materials again to have a cycle, to have a real cycle approach, a circular economy approach, like we call it today? So there's a lot of responsibility also in this field for the civil engineers.
Yeah, definitely. I mean, you mentioned, I think, a very important aspect, and that is impact assessment. We have a strong impact, and we need to be aware of that in different areas, you know, economically, technically, so in terms of society, in terms of environment. And you said what we are aware of now, but we were not always aware of, is that what we build today will be the future resources we have also to rebuild.
Mhm.
And that is a big discussion we have also among colleagues in here in the field of road engineering, but also in other fields. How can we make sure that what we build today is going to be easily and to a high extent recyclable at the end of the lifetime. So on the one hand, of course, creating long-lasting structures to make sure that the energy and that the resources we spend are going to last with a low maintenance need. And on the other hand, everything will come to an end. Of course, also our structures come to an end of their technical lifetime. And then how can we make sure that we can use as much as possible in a simple way without posing a threat to health or environment in general, and reuse whatever is out there, because we have so much built environment by now that this will be more and more of our future construction materials. That's something that we are already in. I mean, it's not we are not in the beginning of that. We are in the
Not
middle
at
of it,
all.
and we that is something that of course is a big part of our program to teach students and make them aware of that, and also show them the perception even before they start to study, because we have, and maybe that is already another topic, but it just comes to my mind. The public perception of civil engineering is not always positive. I think it used to be much more positive in the building years, 1960s, 70s, 80s, when everything was growing and we thought that it's always going to be like that. We find out now, no, it's not. We are not limitless. And I mean, it was maybe a little naive to think it is limitless. There were
Mhm.
numerous studies that we just didn't listen to, that of course nothing is limitless in according to physics, it's not possible. It took a while to realize, but now at least a large part of society understands that. And in all fields, we need to make efforts to make sure that the resources we spend are spent in a way that we don't further fuel climate change and need more natural resources than necessary. But obviously, civil engineering didn't do a well enough job in the past decades to to show to the public that we are already on that road, because we are just not talking about it enough. And especially
Agree.
in road engineering, we have a material that is, we are lucky to have a material that is recyclable to 100%, and it needs to be explained to be explained what that means. It doesn't mean that we can take 100% and don't add anything and just reuse it to 100% without adding something new. We still have to add fresh binder to take into account aging of old binders, etc. But what the great thing is, we have mineral aggregates, stones, and they will not change. I mean, they've been around for millions of years. They don't care about our little 30 years life cycles, right? And we have binders, bituminous binders, a fascinating material. I mean, if you think about it, a drop of bitumen contains hundreds of millions of years of the Earth's history, because it's what's been the plants and other organic matter that's been there millions of years ago. And by natural processes, now we have this fascinating material. What I wanted to say is, so the great thing is we can use stones as stones again, and we can use the binder as a binder again, which is not true for many materials. Uh, and so that's why we have 100% recyclability with our materials. Of course, there are a few exceptions. We need to make sure that they are safe, and there are some older structures that we might to take care of in a different way. But what we're building now is something that we can reuse in the future, and I think that's why road engineering is a role model in civil engineering, showing people we are taking our responsibility. We are not using more than necessary, but we still want to provide you with the means to be able to be mobile, regardless of your physical abilities, regardless also, and that is more on the transport planning side, of your social abilities and your social status, because I think that is important for a continuous, free and liberal society. And roads have always connected people and different cultures. And I think that's what we need to keep doing in the future.
Mhm. Well said. That was very nice listening to you in the last minutes, because there's so much truth in it. I like to pick up some of the points. So we developed in the industry, from the industry side, this sentence that roads have been the first social network in the world. Yeah. So to come from A to B, to talk to each other, to bring goods from A to B, this is why you need roads for. And asphalt is, and there is no doubt about it, the most used road construction material in the world. And at least in the, let's say, at least in Europe, definitely in Europe. And it's also true that we are, since many decades, a responsible industry taking care of that what we take out of an old road, a used road, to bring most of that back again in a new road. So this asphalt reuse, asphalt recycling has always been very high on our agenda in the recent decades. So it's not new, it's that what we already do. And maybe it's the most recycled material in the world, ton-wise. Maybe. I don't have exact figures. It's difficult to find this really, but at least it's on the top of this, or in the top 10 maybe. Yeah, you have steel, you have glass, you have, yeah, and then what else? What else? So so at least in the construction, in the field of construction, asphalt recycling, asphalt reuse is very important, and we do this since decades. And you always also have to say that there's a difference between reuse and recycling. So we want to put every kilogram of asphalt that has been produced once again in new asphalt. So asphalt should remain asphalt throughout different cycles, one cycle after the other. So we have to make sure that it's still reusable, recyclable after each of these series of use, or of its use life or service life in one road. So it comes to another road afterwards. And there's a last point I would like to really put some emphasis on, is the communication. We do so many good things. We also have to talk about it. And this is also a reason of this podcast, to talk to people which are really have a saying, or have something to say, like you, which have a clear position, an independent position in your point, in your point of view, because you are a professor, you are independent, you're totally independent. You don't have to talk what the industry wants to hear. So the communication is very important. We do a lot of good things. We do reuse, recycling since many decades in high amounts. We have statistics for this which show that 70-80% of the asphalt material that's available will come back into asphalt, which is maybe a world record in reuse and recycling. So, and we want to talk about it. And the civil engineering, we started with that, is something that is, in my point of view, underrated and underestimated what it brings to society, and people should be aware. And also when it comes to the specialty of road construction, asphalt pavements, which is my experience or my field of work, especially also yours, there's also something to say, to talk about, and to explain, and to be proud of also, and the society should see and understand. Great. Bernhard, you mentioned there is a change, of course, with all that what we discussed now. That was a development also in the content of the teaching courses that you and other university professors, or professors at high schools, universities, or universities of applied science, which they teach. Can you give us a little bit more insight on that? For me, the sustainability is one of the big words, so maybe you can give us more insight on that.
I want to come back to the very beginning. We saying we need to attract, uh, the people for our civil engineering and road engineering studies, and show them that it's a field where people can make an impact, and a positive impact. Especially road engineering, in civil engineering, does not always have the best perception. I mean, the traffic system is not in every case a sustainable system. If we look at the amount of secondary greenhouse gas emissions, for example, from road usage, so from the trucks and cars that are going there, this is a huge amount. So we have to ask uncomfortable questions again. as well, and say, okay, is the system, which, I mean, we are not creating the system, but of course we are also part of that, because we are delivering the material. Is that really the right way to do it? And why I'm mentioning that is because that is something that I start every lecture by now, telling students, of course, not all is well, but if we don't get critical experts well educated in the field, then nothing will change. And it's important to show and to see that roads are not just for cars. They are a means of transportation and mobility, as I said. But even if you walk, if you bike, if you take public transport, you need high quality surfaces. And that is something that we can offer. And so that is usually important to bring people into the field and explain to them that it's important if we want to make a positive impact on mobility needs of society. So, of course, what we teach is the technical basis, that is necessary, and that is a big part of the basic lecture in the road bachelor program, to say, starting from planning and design. How do you plan a road? Why can you make a turn or a curve with a certain radius? How does that depend on the speed? What about pavement structural design with the different layers? What kind of function do they have? How can you calculate that? How can you use analytical tools to really design your pavements? Pavement engineering is more complex, I think, in many ways than structural engineering. Although I don't want to open up a competition to structural engineers, but we have two big
Don't do that.
we have two big challenges. First of all, our loading is not static. Usually, what you do and you know that, in structural engineering, you have constant loads,
Yeah.
and you have design based on ultimate limit states. What we have to do is we have a cyclic loading, we have dynamic loading, and we have to design on fatigue criterions, which is more difficult to grasp. And the second thing is we have a material that is not linear elastic, which, as civil engineers, we tend to think everything is linear elastic, like a spring, and a lot of our standard materials are, but bitumen and asphalt are not. They are highly temperature dependent. They are highly loading rate dependent. And I mean, that's, where my heart hangs, is personally in terms of research interest. And it's an organic material, bitumen. So it changes over the lifetime due to aging, due to oxidation. And we have to take all of that into account and think ahead 30 years from now, because that's how long our structures should last, at least. I mean, we know that we have country roads out there, and they've been out there for 50 years, and maybe we had some surface replacement, but the structural design is still up
Yes.
and running. As I said, planning, design, then materials. What are the most important properties? That is challenging for students because, as I said, they are only used to linear elastic materials. So we need to explain to them the different in mechanics, the different in behavior. Then how can you assess the quality of a construction in terms of testing? Which test methods do we have? How do they work? What results do we get out? Then, of course, also assessing structures, assessing the health, like structural monitoring throughout the lifetime, to make sure we find out when is the right time to go out and do some rehabilitation, some maintenance methods, make sure that it's not only technically feasible, but also economically feasible in terms of maintenance. And then the big part of recycling. What recycling technology do we have? What are the options? And how do we assess the materials? How do we make sure that we don't add anything, or we don't reuse anything that could pose a threat to health or environment, by running a rigorous testing regime on every ton of material that we extract, make sure it is safe to use. The assessment now is opening up much more. We used to teach technical assessment, mechanical assessment. And then, of course, there's economic assessment, life cycle costs, making sure that you take the right measures to make sure that over the complete life cycle you have limited budgets, because we are always spending people's budgets, right? There's not a lot of private budgets in there. It's tax money mostly in road. So we have to be especially careful about that. And then besides technical and economical, of course, more and more important, environmental assessment. That is something we put into our teaching program. There are methods out there, and we're still not sure which one will be at the end the most usable. And by environmental assessment, of course, it is mostly how much energy do we spend, how much materials do we spend, how much energy is incorporated in these materials, how much greenhouse gases do we emit, and how can we reduce the amount of natural resources and energy to make sure that the footprint gets lower and lower. And we have to be very clear, we have to get to net zero, meaning no new emissions as soon as possible. And we have to develop technology. And that is the great thing, I think, about our field, because it was not always the case that everyone was aware of that. But by now, all stakeholders are aware that we need to take these actions. And road authorities, as well as the industry, as well as we in science, we are working together to find and improve our technologies further, because that is the goal that every branch of industry has to reach in the end. It doesn't make, we can always say, well, yes, but our roads only have about, that's our numbers, 0.5 to 5% of the emissions that the traffic that goes over the road emits over the lifetime. That doesn't make a sense. Every branch needs to take action, even if it's just a small percentage in greenhouse gases. If everyone just sits down and says, well, it's not me, it's the others, it's not Austria, it's China, it's not Germany, it's the US, we're not going to get anywhere. We are all together on one planet. If we want to give a planet to our children that they still have surroundings that are a livable and high quality life, we have to take action. And that's what's happening also in research, and then also in application right now. And we will continue that in the future. And that is important. And that's when I come to the master and PhD level. That's a lot of the things we're now doing in our more research oriented teaching, showing people or further developing these technologies for, if you want to say, green construction or whatever.
That's exactly what I thought that you would say, that there is a shift from the pure technical mechanistic perception also to these other skills, which are more, let's say, driven by environment and health and safety. I would say it's more soft skills that come into the studies that haven't been there before. And I also see this shift in the content of the committees, the technical committees inside EAPA. 10 years, 11 years ago, when I started working for EAPA, we had a technical committee, one full day and a half day health, safety and environment committee. Now we have a fully packed agenda for the HSE committee, and especially on environment, and the technical committee is still on the same level. So a lot of topics came on top from the environmental perspective and the health and safety perspective. And it's great to hear that this is also reflected in the universities today, in the civil engineering studies, or especially in the pavement engineering studies.
If we don't teach it now, how are experts of the future going to apply it? So we have to. I think that's the responsibility of universities and those higher education facilities, to have a vision of the future and implement it as soon as possible, even if we don't have the perfect tools yet. At least make them aware of, this is going to be something you need to be working on as experts in the future. And
maybe they will develop these tools.
Yeah, exactly. And so that's why I think it's important, and that's why, of course, they are implemented in many fields and also in our field.
How have the numbers of students developed in the recent years?
I just had since I'm at a conference and I met a lot of colleagues and I discussed it over dinner 2 nights ago, asking them how are your student numbers coming along.
Mm.
We see stable numbers to slight decreasing numbers. Of course, that is also reflected by demographic changes because we have, of course, a smaller pool of young people, unfortunately.
Yeah,
But
unfortunately.
we also have competing programs, and that is not meant in a negative sense. But we started a new program, like many other universities, on environmental engineering,
Mm.
and that had a very strong draft of young students, and we saw that we had a shift from civil to environmental engineering. However, that was temporal, because of course it's always interesting if something new comes up, right? I mean, there is this draw of newnessness that I can understand. By now, it's balanced out. So in total, because we are now, like many other faculties around the world, the faculty of civil and environmental engineering. So overall, we have a much larger amount of students, number of students, um, uh, because it's split up in environmental and civil engineering. For civil engineering, as I said, we are stable to a slight decrease. Of course, we would
Mm.
be happy if we had a couple of more students, because I think that there are many challenges ahead. And I know that in many areas, the industry as well as public authorities, we need experts in the
We need
future.
them. Yeah.
Yeah,
Yeah, we need this kind of engineers, the civil engineers and the environmental engineers, to build the future of our lives, of our society. You know, to have this built environment, make it happen, make it real, and make it sustainable, real, and net zero, and make it a new net zero reality. I
yeah.
fully agree. One last question on this: how is the ratio between male and female students?
There's a positive trend. You know, when you started, when I started, so I started about a lot more than 20 years ago, which again brings us to the
You
to
are
the
not in your mid-20s
relativeness
anymore.
of age. But back then we had about 10%. In my year, we had about 10% of female students, so very low numbers. And I have to say that back then, the environment at the university was sometimes really, I have to say, hostile, especially in
Mhm.
technical studies. And that was, I would say, that generation is now in retirement, and there is a strong support programs, because we strongly look into balancing out this gender in civil engineering. So by now we have about 30% of beginners, of female students, which is something we are proud of because we did a lot of support measures, but also giving female role models. I think that is very important. I mean, you would have to go much earlier in education. It's important to make sure that even in very early education, I'm talking kindergarten level and that way, that it is
Mhm.
clear that role models, whether it's children's books or whether it is how we talk to our uh, girls and boys and daughters and sons, and what we expect of them in terms of behavior, reflects on what they want to become in the future. Um, and so I think that's important. And we saw, of course, that our society opened up, and that those rigid role models are not there anymore. You know, let's say 20 years ago we were at 10%. Now we are at 30%. If it takes another 10 to 20 years to get to 50%, and we reach that, then I think I will be happy, because it is important. I see that in small scale in my team, where we also don't have a gender balance yet, but we have female researchers, young researchers in the team, and it is so important, and not only in there, but in all of civil engineering, because it just changes the approach. How do you approach problems? How do you find solutions? How do you communicate? And all of that changes the way civil engineering is working, and that is also due to making sure that women who are interested in techniques, and there is a bunch of women in
Of
interested
course, why not?
in technology, are encouraged to take that path.
We cannot allow ourselves to leave out this part of the society. So all the ladies that could become civil engineers, we cannot simply not allow ourselves to miss those. We need them in for our field. It's another 50% that we could get, and we have to. And as you said, I also experienced that throughout my working life, that there's a little bit different approach on projects, on problems, on challenges from the female engineers, and this is really helpful for the whole industry and for the whole engineering, I have to say. Wow, Bernhard, that was a lot of important messages from your side. I'm deeply impressed. I'm not surprised, but I'm again impressed. It was great talking to you. A very interesting episode, I would say, and I was fascinated about the insights on the civil engineering, the role of the pavement engineering, what you just told us, the changing in the priorities of the studies, and especially the impact assessment and the environmental assessment, which is, I think, absolutely necessary for the future, that we know why we do it, and how we do it correctly, and that we have a kind of a measuring system to do this. And CO2 emissions is one of it. And also the efforts of the industry to reduce CO2 emissions, and that it is a joint effort and not just the civil engineers alone, the road construction engineers alone. It's the whole society, it's all stakeholders, it's all together. Might it be in the US, as you said, in China, in Europe, wherever, we have to do that together. Okay, so Bernhard's insights were incredibly valuable, and the conversation, as always, was engaging. I hope you enjoyed this episode as much as I did. As usually, all relevant information and links can be found in the show notes and description. Don't forget to follow us on social media, leave your comments, and tell us what you enjoyed most and what you'd like to hear next time in the RoadCast. Stay curious, and see you in the next episode.